Okay, in this problem, it says we have a ball thrown from an initial height of 164 feet at a downward velocity of 12 feet per second. The ball's height is in feet is given after t seconds is given by the C equation. When does it hit the ground? So essentially, all these points on this downward trajectory, so this ball is going to kind of curve and then eventually it will hit the ground down here. But if I think of an arbitrary point on this, then typically this is after time t. It has some height. So the x value, the traditional x value is our time, and the traditional y value is our height. So if I go down to here where it's going to land, it's going to be some t, I'll call it t1. But the height down here, I don't know the height really anywhere between the 164 and the ground. But on the ground, it's a height of 0, h equals 0. So since we have this equation here, h equals 164, yada yada, what we can do is we know the height is 0, we can just replace that in the equation. So we get 0 equals 164 minus 12t minus 16t squared. So now I just have to solve this, and typically we'll solve this with like a quadratic formula. I might just move everything over to the right. I kind of like to make my a positive. This is not a requirement. But I'm going to divide everything by -2. I can divide by any number, and -2, I see they're all even, so I know I can divide by -2. Because what that'll do is it'll give me a 0 here, and -16t squared divided by -2 will give me positive 8t squared. I'm just going to kind of put it in order, plus 6t. And then if I do 164 divided by -2, I will get 82. So that'd be -82. And if I want, because they're all even still, I can divide by 2 again. And this is not a requirement. If you want to do quadratic formula with the bigger numbers, you are certainly welcome to. But the smaller you make it, the less calculation you have to do when you get your quadratic formula. So this will boil down to 4t squared plus 3t minus 41. So I like to make the a value positive. I like to divide out by anything I can, just to make my calculations just a little simpler. So what I'm going to go ahead and do is I'll now do the quadratic formula. So if you remember, quadratic formula is -b plus or minus square root b squared minus 4ac all over 2a. Now in this case, our a is 4 because it's in front of the x squared, the t squared. Our b is 3, and our c is -41. So plugging in, we get the opposite of b, so that's going to be -3 plus or minus square root 3 squared. I like to put that b in parentheses because if it's negative, that will help us. Minus 4 times a times c all over 2a, so 2 times 4. So now the discriminant, which is all the stuff under the root, we can figure that out. So that would just be kind of these numbers here calculated. So that's going to give me 665. And that is going to be over 8. Now, the square root of 665, we can figure out what that is. And this is where our rounding to the nearest whatever. In this case, it says round to the nearest hundredth. So if I take the square root of 665, it's going to be -3 plus or minus 25.79. That's the nearest hundredth. It's 25.7875939 divided by 8. Now in this case, what I do know is I don't need the plus and minus, because if I do -3 minus this number and divide by 8, I'm going to get some negative time. And there's no way that the ball can land in a negative amount of time. Now there are some cases where the negative might be an appropriate solution, but in this case, we do not need it. So we'll take the -3 plus the 25.9, and then I will divide that by 8. So that's going to give me a bunch of numbers, 2.848, etc., etc. But if I round it to the nearest hundredth, it's going to be 2.85, and that's going to be seconds. Now I use x because that's the traditional thing, but this x in our case was just t. So this essentially is our t value. So after 2.85 seconds, it should be at a height of 0. If you want to check, and a real easy check is take your equation, 164 minus 12, and plug in 2.85. Now, it's not going to work out perfectly because we did some rounding, but if you put this in your calculator, you will get something that should be very, very close to 0 feet. And that's when it hits the ground.